Hi, my name is Peyton Dagg, and welcome to Project Str-Eng. I didn't know much about engineering or physics, and I'm on a mission to learn from industry professionals about what it takes to build the structures around us, whether it be our apartment buildings or the bridges we cross on the way to work. Join me as I try to understand how structural engineering affects our day-to-day lives, how structures are built, and what makes iconic structures so special. Today's episode is on force, a fundamental and key element of structural engineering. History. If you watched our previous episode about gravity, you may remember that everything started with Aristotle's theory, which was proven wrong by the mid-16th century. Sir Isaac Newton developed his theory of universal gravitation a century or so after. Oddly enough, the history of understanding force is very similar, and even involves some of the same characters. So it started with Aristotle's theory again. His theory about force was that continuation of a motion depends on the continued action of a force. In other words, he believed that a force is required to maintain motion even at a constant velocity. And guess what? He was wrong. Again. Aristotle's theory began facing criticism in medieval science, and all of his misunderstandings were eventually corrected by Isaac Newton. Did you know that there are some non-contact forces that are strong enough to move a train? A maglev train is a train that uses no engine, and only moves by the power of magnetic forces pushing against each other. Magnets on the bottom of the train push against magnets on the tracks and levitate the train by about 10 millimeters. These non-contact forces push against each other constantly, and the train can move up to 580 kilometers an hour. Anyways, in the late 17th century, Sir Isaac Newton published his laws of motion in his book titled The Mathematical Principles of Natural Philosophy. In this work, Newton set out 3 laws of motion that to this day are the way forces are described in physics and engineering. Forces are essential in various engineering disciplines as they play a crucial role in designing and analyzing structures. My friend Will stopped by to teach us about the concept of force and what it means. The interview. So, what is force?
In the realm of physics, a force is a very fundamental concept. It describes the interactions between objects. And force comes in different ways. There can be a push or a pull force. It is a vector force, meaning it has both magnitude and direction. So when you open or close a drawer, you can choose a direction and you can choose the strength of force that you apply. There are many ways we can categorize forces. We can look at non-contact forces and also contact forces. A good example of a contact force would be kicking a basketball or kicking a soccer ball or shooting a basketball. A good example of a contact force would be pushing or pulling on a door or a drawer. We can choose the amount of magnitude of force that we apply to it, so that's how efficient we are in opening the door. We can also choose the direction. And so when anything has a direction or a magnitude to it, we call it a vector force. Some examples of non-contact forces would be magnetic, electrical, or gravitational forces. Anything that's not in direct contact with each other.
So how do we use force on an everyday basis, in our everyday lives?
We use forces all the time. Whenever we move towards something, whenever we accelerate, any change in direction, all these require forces.
How do you use force in structural engineering?
Structural engineering is the study of forces in a static context. Every time we analyze a structure, we look at what forces are being applied to the object, how strong these forces are, what direction these forces are, and we have to take all this into consideration to create a safe environment.
So why engineering?
It's immensely satisfying to solve problems. I'm still very young, I'm exploring it, and I can't wait to see some of these solutions I am designing be implemented in the world around me.
What's your favorite formula?
Something simple as force equals mass times acceleration. It's Newton's second law. It's very fundamental, but it describes so much of the world we see around us. It's one of the bases of engineering.
Which sport do you use the most force in, you say?
Well, all sports require force. If you think about hockey, that's an interesting example where you are skating on the ice. When you push and accelerate towards a particular place, you are exhibiting force.
Is there such thing as too much force?
Of course, in structural engineering, you want to analyze the force and you want to appropriately resist all of the forces that are being applied. And so whenever there's more force, we have to put that into consideration and design accordingly.
What is a Newton? I thought Newton was a person.
Yes, Isaac Newton was very fundamental to engineering. He established the 3 laws of force. One of the ways we quantify force is through the Newton. It's an SI unit, meaning it's very fundamental. And a Newton of force is how much force is required to make 1 kilogram accelerate at 1 meter per second squared. Newton's first law states that an object will not change its motion unless an unbalanced force is being applied on it. Let's consider this train in front of us. We see that it is not accelerating, so we know that there are no unbalanced forces applied. If we turn it on, however, If we turn it on, however, as we see it accelerate, as we see...
We should have just played basketball.
We should have played basketball.
Lego man.
However, as it begins to accelerate, we can say, according to Isaac Newton's first law, that there are unbalanced forces on it because it has a mass and it is accelerating.
Oh.
As I mentioned previously, force is a vector, meaning that it is both magnitude and direction. As we see it switch direction, we know that forces are being applied on it in a different context, and because there's acceleration, we know those forces are unbalanced.
So basically, force is a very fundamental concept as it describes interactions between objects. Force is a vector, meaning it has magnitude and direction, and contact force is like kicking a soccer ball. And some non-contact forces are magnets and gravity. Newton's first law of motion, also known as the law of inertia, states that an object at rest will remain at rest, and an object in motion will continue moving in a straight line unless an external force acts upon it. In simpler terms, objects tend to keep doing what they're doing, unless something makes them change. Newton's second law of motion, which is F equals ma, is the basis for engineering. And there is a third law of motion, which I hope to explore in a future episode. Newton is not only a person, but also an SI unit of force. 1 Newton is how much force is required to move 1 kilogram of mass at the acceleration rate of 1 meter per second squared. Thank you for watching another episode of Project Str-Eng. A special thank you to Will for teaching me about force, and a special thank you to you for sticking around until the end of the video. While you're still here, subscribe to our channel to learn more about structural engineering with me. I'm Peyton Dagg, and this has been another episode of Project Str-Eng. Don't forget to enjoy the process. If you were driving a train and there was a pile of 5 people on the tracks and then a baby on the other track, and you had to choose which one to run over, which one would you choose?
I'd preserve the more life, probably.
So you'd kill a baby?
Would you?
I don't know, I haven't thought about it.